absent. All right, we're going to look at sequences today. And a sequence is just numbers, 2, 4, 6, 8, whatever. It's a list of numbers. But we're going to specifically look at two different ones. We're going to look at arithmetic and geometric. Are those the only two sequences? No. There's many sequences, right? If in biology, you may have looked at the Fibonacci sequence, which the petals of flowers and leaves around a stem, there's a lot of places where you see those. But we're going to start off. These are easy. It's going to be a review for you with these arithmetic because you looked at them in Algebra 1. You're going to recognize them because basically an arithmetic sequence is linear. So it's very easy. You're used to it. So write the equation. We're going to get used to some vocabulary first. Explicitly defined. We're going to look at those. That's where we're plugging numbers in and we know exactly what we're going to get out. So if this says write the first 5 terms, what that means it wants you to do is it wants you to find A1. You plug 1 in. If it tells you to find the first 5, we always start with 1. So that's very easy, right? 2 times 1 plus 1 equals 3. And then A2, we're plugging 2 in. So 2 times 2 is 4 plus 1 is 5. A3, we plug 3 in for n. 2 times 3 is 6 plus 1 is 7. Of course, I run out of room. A4, we're plugging 4, right? 2 times 4 plus 1 equals 9. And A5, we plug 5 in. 5 times 2 is 10. 10 plus 1 is 11. Now, remember when we looked at Pascal's triangle, I told you this unit is all about patterns. What do you notice about these answers as you plug each number in? They go up by 2. What's the slope? 2. So notice this. Now, not everything is linear, but when you see something that could be 2x plus b, 2n plus 1, the slope is going to tell you how much you go up. So it makes your math really easy, right? You don't really have to do the work. Okay, let's look at B. What happens with this little guy? Well, A1. And I'm going to write these out because this one's a little trickier. So what is that? Negative 1 to the 1 is what? Negative 1, right? And 2 minus negative 1 is, this becomes 2 minus negative 1, which is really plus 1. So that's how big? 3, right? Now we're going to plug in a 2. So we have 2 minus. Now what's negative 1 squared? Negative 1 squared is 1. So 2 minus 1 is 1. Now we'll look at A3. This is a 1. And when I raise 1 to a power, what's the answer always? 1. My only difference is it going to be negative or positive? So this time we've got 2 minus negative 1 cubed. So what's that answer going to be? Well, we got 2 minus negative 1, which is what? 3. So we go 3, 1, 3. So do you see a pattern here? What's A4 going to be? What's it going to be? 1. And you start to see that these are alternating. So you always want to look for patterns. Patterns speed things up. Are you allowed to plug numbers in? Of course you can plug numbers in. But if you notice a pattern, now I could give you A99 and you'd know the answer was 3. If I gave you A98, you'd know the answer was 1 because you can see that this fluctuates between 1 and 3, right? It was 1 raised to a power, so that's always 1. Okay, what about this one? Well, just plug them in, right? A to the first equals 2 plus negative 1 to the first over 1, right? A2 is 2 plus negative 1 to the 2 over 2. So take a second and let's do those. Again, we're simply plugging a number in. We're getting used to an equation. and all the different sequences. These aren't necessarily special yet. We'll get into our special ones in a minute. So what is that? 2, 1, 3 halves. 1/3. Do you see a pattern with these? You see a pattern with these? So if I asked you to keep writing these, would you need to keep writing them? Do y'all see a pattern? What's the pattern? What do the numerators do? Yeah, and technically I could write 1/1 there, right? What are the numerators? 1, 3, 1, 3, 1. And what about the denominators? Yeah, it's whatever you're plugging in, right? So if you notice that pattern, you could continue on without doing the arithmetic, right? And that's one of the things you want to get used to is looking for patterns. Okay, we're going to talk about a couple special ones now, the arithmetic sequence and the geometric sequence. We'll start with arithmetic. This is your formula, and y'all make sure your masks are on. You have to keep your mask on in class. Okay, so we look at A1. A1 is your first term. Okay, so A1 is where you're starting. If I start with 7, 7 is my first term, right? N is how many terms you have. Maybe I tell you I want you to write the first 6. Then N would be 6. D is the common difference. How far apart are my numbers? So let's just see if we can identify the variables. 5, 8, 11, 14, 17. First thing I want to do is see if there's a difference. How far apart are 5 and 8? 3. 8 and 11 are 3. 11 and 14 are 3. 3. So the common difference is 3. If there's not a common difference, it's not arithmetic. Okay, to be arithmetic, it's got to be the same number. It can't change. A1 would be what? 5. AN refers to the last term. So in this particular one, AN is 17, and N is 1, 2, 3, 4, 5. Okay, so does that help you figure out what all these little variables stand for? Okay, so let's look at the next one. All right, what is D on this one? How far is it from 9 to 5? Going down 4, so that's negative, right? -4, -4, -4. It's always good to check a few because that number could be changing, telling you this is not arithmetic. Okay, so difference is -4. What's A1? 9. AN? -7. And N? 1, 2, 3, 4, 5. Any trouble identifying the pieces? All right, how about this guy? Well, what's the difference here? Well, what's 7 sixes minus 1? That's like saying -6/6, right? So that's 1/6. What is 4/3 minus 7/6? We need to get the same answer each time, right? So this is like saying 8 sixes, right? 4/3 is really 8/6. 8/6 minus 7/6 equals 1/6. What about 5/3 minus 3/2? Is that 1/6? So we know that our common difference is 1/6. So if you get a fraction and you don't automatically see it like we did with these other ones, simply take a term and subtract the one before it and see what the difference is, right? So every time what we're doing is adding a 6 to that fraction. A1 is 1, AN is 5/3, and there's 1, 2, 3, 4, 5. Now in our examples, N was 5. Is N always 5? N is not always 5, okay? All right, let's see what a problem looks like now that we're used to the variables. And of course, you can write your formula down, right? AN equals what? A1 plus N minus 1 times D. Now you can rearrange that formula and put the D in front of N minus 1 if you want. This is just traditionally the way it's written. And I'll give you a formula sheet when you take a test or something so you don't have to flip around. Okay. Find a formula for the nth term of the arithmetic. Definitely need to know that, right? Because this is for an arithmetic sequence, whose common difference is 5 and whose first term is 1. So the easiest thing to do is say, okay, I need A1, N, D, AN. Figure out what you know out of those variables. So it says common difference is 5. First term is -1. Now remember, this doesn't tell you to find an answer. It says find a formula, so you're going to be writing an equation. So we're just going to plug it into that with everything that we know. So AN equals -1 plus D times N minus 1, right? I like to write my D on this side. So once you plug in A1 and D, all you do is simplify. So AN equals -1 plus 5N minus 5. So AN equals 5N. And then if I put those two guys together, minus 6. Okay, when you're finished with an arithmetic sequence, it should look like a line. 3n plus 4, 9n plus 7. This one is 5n minus 6. So when you see find a formula, they just want you to get here. You don't have an answer. You're not going to say the answer is 7, right? Okay. Find the 10th term of an arithmetic sequence that begins with 8 and 20. So again, what did they tell me? It begins with 8 and 20. That means 8 is the first number, 20 is the second number, and so on. So I know A1 equals 8, A2 equals 20. Can I find D since they gave me these two right in order? Yes. What's the difference between 8 and 20? 12. What else do I know? There's one more thing they gave me. So I know that N is what? N equals 10. I'm going to put that in pink so you recognize where did we figure that out, right? So we'll try to write our formula. So A10 equals A1 plus D, what's D? 12 times N minus 1, right? Here's our N, here's our D, here's A1. Label those. These are really easy, but you have to know what number is what variable. Now we'll just finish this up. Right? There we go. The other way you could do this is you could just list them out, right? You could list 8 and 20 and keep adding 12 on until you got to 10 terms. We don't want to rely on that because what if I said find the 300th term? You don't want to sit there writing a sequence of numbers out forever, right? Does that make sense? Do the variables, do all the parts of this equation make sense? Okay. The 8th term of an arithmetic sequence is 25. Okay. The 8th term is 25. That means A8 is 25. The 12th term is 41. Write the first 5 terms of this sequence. Okay. Well, would y'all all agree that 8 plus 4 would give me 12? So if I took the very first, if I took A8 and I added 4 differences to it, would I have A12? Does that make sense to you? No matter what number you have, you add differences to get to the next number, right? So does this make sense? The 8th term plus 4 more terms gives me the 12th term. Okay, and I can plug this in. Right? Not so hard when we do that. I subtract 25. Is that 16? We found D. Now, in order to write the equation, because it's asking me to write the first 5 terms, so I need the equation. I want to write this down, right? So if you knew A8, could you find A1 easily? Could I say that A1 plus 7 differences would give me A8? Is that true? Is 1 plus 7 8? Okay. I don't know what A1 is, but I certainly know what 7 times 4 is, right? I can put 4 D's. I found D. And I knew A8 to begin with. I chose A8 because that's what they gave me. So what is A1? -3. So now I can do what they asked and write the first 5 terms, right? -3 plus 4 is what? Because we're going to add the difference on. 1 and 4 and 4 and 4. 13, right? So there you go. We always have to read the instructions, write the first 5 terms of this sequence. And I want you to be good at writing an equation. I don't want you to sit here and say, well, if I found the 8th one, I'll just subtract back. Because I could ask you any weird number like the 400th term, and you need it to be easy to be able to find those. Does that make sense? So an arithmetic sequence is basically a line. And when you get it written out, the slope is the difference, right? The slope is that difference. So arithmetic means we're adding, even if we're adding a negative number. If I take 2 and I add 3 and then 3 and then 3, it stays constant, right? It's a constant increase. We also have, guess what else we have? We have geometric sequences. Geometric has a common ratio instead of a difference, meaning I'm multiplying something to get to the next number. That make sense? So geometric, you're multiplying. So we have A1, which, what do you think A1 represents? It's the first term. R is the common ratio. N is the number of terms. Right? So let's practice figuring out what all of our letters are. So in this one, if you didn't know this was geometric, you might see if it's arithmetic and you'd be like 3 plus 6 is 9, 9 plus 6 is 15. Okay, we know it's not arithmetic, right? So the other one we would try would be geometric. How do you get 3 to turn into 9? You multiply by what? 3. And then 9 times 3 is 27. 27 times 3 is 81. 80, yes, it's the same every time. So this is geometric. R is 3. What's your first term, A1? 3. Now AN. Do we know AN? We don't know. Why don't we know? Because there's dots here. Dots means this goes on forever. So we might not know the last term. True? Maybe we don't know it. N means how many terms are there? If it goes on forever, do we know, do we have an N? We don't have an N. N means there's 21 or there's 5 or however many. So there's really no N here. Okay, what about this one? B, what is R? How do you get, what do you multiply by to get the next number? 2. So R is 2. A1 is easy, that's 10. Again, do we have an AN in this one? We do not, because of these 3 dots, and it's really important that you notice that. That means this goes on forever and ever. So we don't have a last one, and we don't know how many there are. We can't answer those questions. All right, what about this one? Well, let's see. I can do A1. I could do AN. There's no dots this time, and there's 4 of them. How do I find R when I have fractions? All you have to do to check for R is take any number and divide by the number before it, because you want to know what multiplied, and what do you do to figure out multiply? You divide. So take 1/16 divided by -1/4. How do we divide fractions? That's 1/16 times -4/1, right? So what is that? -1/4. Now I can't just do one, right? I got to check a couple of them. It might not even be geometric. So now I'll take -1/64 divided by 1/16, which is really -1/64 times 16/1. And what is that? -1/4. So what is our R? So remember, if you have a fraction, I know y'all don't like fractions, you just take any number and divide by the number that came before it. You should get the same answer each time if it's geometric, right? Everybody okay? Are we good? So you have this formula written down. I'm going to write it right here so it shows on the screen. Right? I like it nice and close because I'm going off the screen. So write the first 5 terms of a geometric sequence whose first term is A1 is 2, and whose common ratio is 4. So AN equals 2 times 4 to the n minus 1, right? It says to write the first 5 terms. So I'm going to write A1 equals 2 times 4 to the 0, which equals what? 2, because that's 2 times 1. A2 is 2 times 4 to the 2 minus 1, which equals what? 8. Now, do I have to keep going? Or if the common ratio is 4, do I know just to keep multiplying by 4? So I really know that it's 2. 2 times 4 is 8. Times 4 is 32. Times 4 is 128. Times 4 is 512. So there's my first 5. I have a choice. Once I know the formula, I can keep plugging them in. I can do this all the way down, or I can say, whoa, I know the common ratio, and if I know the common ratio, I just have to keep multiplying, right? Is everybody okay with how you got that, how we got these? Not bad, right? And again, you don't have to commit those to memory. You can write them down. All right, we got a couple more, and then we'll be done. All right, let's write our formula down. What's our formula down? If you're at home, and I'm not printing, I printed the formulas for people here, but if you guys are writing on paper, just write both formulas down on a sheet of paper. Start a brain for this unit because we'll have a few formulas and you want all of those available. You don't want to be flipping through notes, right? Okay. Find the nth term of a geometric sequence whose first term is 4 and whose common ratio is 0.5. So you know I always like to identify my guys out here. Right? So find the 9th term. So what does that tell me about n? N is 9. Of the geometric sequence whose first term is 4, that's A1, and whose common ratio is 0.5. You could also write 0.5 as 1/2 if it makes your math easier. So all we have to do is fill them in, right? A9. And the n just represents the number. So if we're finding the 9th term, we'd write A9 equals 4 times 1/2 to the 9 minus 1, or the 8th, if you will. So I'll let y'all punch that in. You can use your calculator. It's basically 4 times 1/2 to the 8th. So 1/64. It's 2 to the 6th, right, on the bottom. So there we go. Is that okay? We got it? Okay. Write the formula and find the 10th term of a geometric sequence, 6, -2, 2/3 here. Let's write our formula down again. I'm actually kind of hoping that if we write it enough, you don't really need it. That's why I keep writing it. Okay. So do we know A1? What's A1? 6, right? The very first number is 6. Okay. Do we know n? Yeah. When they say find the 10th term or anything like that, that's n. Can you figure out r? What do you multiply 6 by to get -2? Just remember, take a number and divide by the number before it to figure out r. So that's -2 divided by 6, which is what? -1/3, right? Okay, so we have A10 equals 6 times -1/3 to the 10 minus 1. So feel free to punch that in. You may use a calculator for your arithmetic. I did mine as a fraction. You may have a decimal. Make sure you can do both, right? So let me show you something on your calculator. If you plug it in like this, right? If I plug it in like that, whoops, did I forget I forgot my multiply. Okay, 6 times y'all, what? Oh my gosh, sorry about that. Okay, let's try this again. Right, you can put it in that way and you're going to get a decimal. If you put it in this way, right, do alpha y equals 1. Well, it should give you a fraction. Huh? Okay. Well, I would do this when if I were typing this in and you want a fraction, just do -1 to the 9th, which of course is -1, and then 3 to the 9th, and kind of do it by hand. But anyway, or you can do math fraction. Nope, it won't put that one in. Strange. Okay, any questions? Sequences make sense? Remember, you're just looking what number comes next, and it's always the same today, right? We're either adding a number on or we're multiplying. but it's going to be the same pattern. As soon as you know one number, you can find all the other numbers. It's not going to change. All right.